All good afternoon or good morning from wherever you are. Welcome to our 34 webinar lecture on our webinar series. So today we have a pleasure and honor to host Marcel on our platform, and he is actually the senior consultant. Just a moment. He is an animateur of ITA Working Group 11 that is on submerged tunnels, and he works for Royal Haskoning DHV on different complex projects. His contribution to several solutions and complex designs are acknowledged by clients. On his portfolios are airport, marine infrastructure, and utility structures. As a part of team of specialists, he supports the office on specific design challenges. His current work is related to immersed tunnels for tunnel engineering consultants, that is a JV with Royal HV, and he is also a PhD candidate at TU Delft. And on a personal note, I met him on my Gadans workshop. Uh, that is a Isocarp and Itacus joint venture, you can say, and it was really good having him. He was our supervisor, coordinator, a good friend as well. And he has also been awarded a Royal Award for his outstanding contribution to the society. So we welcome you, Marcel, over here to our platform, our webinar platform. Over to you, Marcel.
Okay. Well, thank you for this kind introduction. And well, some of the things you said are also in my presentation. But first of all, thank you for the kind invitation, and it's my pleasure to give this lecture today. I will share my screen. I think from a practical point of view, it's good that we have a discussion or questions after the
Yeah.
presentations. Feel free to put them in the chat so we can relate that directly after the presentation.
Yeah, so just put your questions in the chat, and at the end of the webinar, I will be addressing all the questions and he will be answering it.
Exactly. So first of all, you asked me to tell something about immersed tunnels, and I can't do that without referring to Archimedes. And so I titled this presentation, The Unlocking Archimedes Principle, the Strength of Immersed Tunnels. And I'm all about to tell you about it. Well, this is the guy. And on the left side, beardy guy, he was in Greece. And he's one of the famous physicists of that time. He also did a lot of work on pi, so the 3.14159. You know all the numbers, but here it's related to this shampoo bottle, and I think you all went swimming somewhere and having such a bottle, and then well, you put it underwater, and then you feel, oh, it wants to go up. And actually, that's the Archimedes principle, and that's related to this kind of tunnels. So, but the principle is that any object, totally or partially immersed in a fluid or a liquid, is buoyed up by a force equal to the weight of the fluid displaced by the object. I think you have all learned that on university or even on high school. But that's the main principle behind this type of designs. And it's quite old already because it started around 1910 with the Detroit Rail Tunnel. They don't look like this anymore. And you can see here, it looks kind of round tubes, and the ballast is on the outside, and there are some floaters on the roof. And the last immersion you see here is an immersion close to Rotterdam. Actually, it's in my backyard because I live somewhere, well, about a kilometer from this point. And it's an immersion of the Maas Delta tunnel, and I will tell you later on it. The presentation, the contents, and somehow it's not really strict, but first I will introduce myself and the company, and then I will go over why, where, how, what, and all other questions which are related to these immersed tunnels. Then I go to the headlines of it, the construction, the installation, and the finishing of these tunnels. I will give you some project overview of the femur belt, but also of the Busan Guai link. And afterwards, we have some questions and discussions before we have a closure and have a nice weekend. So that's my proposal for this afternoon. So, well, that's me. Uh, don't look at the picture. I've seen it a lot of time, but you get bored from it. Actually, I'm working. Well, my employer is Royal Koning DHV, as Rush already said, and there I'm involved in complex structures. So if a design is complex or there are problems within the design, hopefully they call me, and hopefully on time, so we can do something about it. And it's usually based on advanced FEM. So it's about cracking of concrete, plasticity of steel, soil dynamics, regular dynamics, all kind of typical, really complex things which are not day-to-day business in a regular engineering office. And since 2010, I'm usually related to tech, and tech is tunnel engineering consultants. I will go over that part later on. And there I'm involved in the structural challenges, but also the geotechnical challenges, because we do not only do immersed tunnels, but also bore tunnels and other deep excavations. Furthermore, I'm animator of, or animateur, as they would say for ITA, for work group 11. And the ITA organization, you know that as well, is split up into different work groups. And this work group is delegated to this immersed tunnel. It has quite an active audience. It has about 40 active members. Uh, most of them are working on immersed tunnels, and research part is working on the floating tunnels. And I'm kind of on the edge of both. And recently in Athens, we presented the owner's guide for submerged floating tunnels, which can be downloaded from the ITA website. And as a last point, I'm also PhD candidate at Delft University, and I'm doing my research on the risk and reliability of submerged floating tunnels. Different topic, related, but not for today, maybe for another time, if you would like that. Well, Tech Tunnel Engineering Consultants is founded in '89, and it started with a Dutch tunnel. And originally we were with 3 companies, but 2 of the 3 were merged. So Royal Koning and DHV were 2 separate companies. They merged together, and now we're with 2 companies. And all tunnel related things outside the Netherlands we do together, but there are sometimes things within the Netherlands we do separate, or outside the Netherlands we do also separate. So it's not real strict, but we cooperate in the design of and also review of tunnels for clients. We do not only do the structural review, but also the electrical, mechanical installation, safety aspects, and all kind of things which are related to tunnels. Current projects. Here I already showed you the Maas Delta tunnel, and there are 2 tunnels next to each other. The femur belt, which is later on in the presentation. The Shenzhen Nanping in China. The Schelde tunnel, which is in Belgium. So if you know Belgium as around Antwerp, there's a real challenge in traffic. So they want to solve it using some tunnels. And the Suez tunnel. We have some tunnels in design phase. The King Salman crossing, which is a submerged floating tunnel somewhere in South Saudi Arabia. The Weser tunnel, which is close to Hamburg. And there are some research programs running on the submerged floating tunnels. But while I was making this presentation, I realized that there were many more. I think we have 7 or 8 tunnels which are in design phase, starting design, or starting in the proposal phase, or something like that. And we do also renovation and maintenance. So most of the infrastructural works in the Netherlands are being built after World War II, and they are kind of at the end of their design stage, or at their lifetime, economical design lifetime, and they need to be updated to fit the current design standards which we require for tunnels. So we renovate them, and sometimes related to fire or to leakage or corrosion protection, things like that. We do all these kind of things within our company. Um, and we do them worldwide. You see here, this is a picture of the Busan Guai tunnel, which is a large tunnel project, which is later on in the project, but it brings us all over the world. We do it not only in the Netherlands, but worldwide. If you look to the tunnels we did in the Netherlands, well, this is just a short list of the things, but they're all the tunnels which are made after 89. All of them are immersed tunnels. They're all based on immersion. And here you see the aqueduct Harlingen. And to my friends we met in Gdansk, this is something we would like to see over there because it's similar to the project required in Gdansk. You see a lot of people here looking at this immersion project. It's always nice to see that people have interest in what you do. So this is the Dutch part of the projects. Here are the international projects. Here you see the Hong Kong, Macau, and the Öresund links. There are a combination of bridges and tunnels, also Busan as such a configuration. Here you see Unkapani, which is actually it's kind of bridge underwater. It's submerged, but it's very challenging because Turkey is a seismic area. So we design also these kind of tunnels in seismic areas. And well, as I said, all over the world. So Scandinavia, but also in Asia and the southern of Europe, and also in the northern part of Europe. So now that's enough of marketing. Let's go to the tunnels itself. Why and when do you want an immersed tunnel? That's regularly the question we got asked, and the best way to present that or to explain that is to compare it to other techniques, and you see the advantage between the different solutions. If you have a bridge, you have a long approach, and if you have a bore tunnel, it's deep and has a longer approach. While an immersed tunnel can be very close to the bottom of the crossing you have. It's about only 1.5 meter of cover below the bottom of the river, and that makes that it's less deep and the approaches are smaller. So you have a less or you have a shorter tunnel because of that. Second to that is that if you have a bridge, you need to have a higher, you need to provide clearance for the ship. So your bridge need to be high, yeah, that causes that long approaches. So here are some pictures of these kind of things. So if you have a harbor and you would like to accommodate these large ships, then you need a large bridge with a high clearance. Or here in London, in the Tyne River, you can make a tunnel, and then, well, you accommodate quite easily these ships, and you have a full clearance for it. Can you do it everywhere? Well, practically in every waterway you can do this. This is this is a part of Rotterdam. It's even close to a bridge, and here we made the Thomas tunnel. This is the second Benelux tunnel, I think. well, I'm not sure, but well, here we have a building dock close to the immersion location. Here I will talk about that later. It's the center of Amsterdam. Here's the central station, and we immerse a tunnel below the central station. So this is the eye lake, and we bring in the immersion element and bring it underneath the structure and immerse it below that. And the most challenging project, which is currently going to start at the moment, is the Femur Belt link, which has a length of about 18 kilometers of immersion, contains out of 90 elements. And also practically every shape or form is possible. I think I showed it here. So you can accommodate both trains, traffic, pedestrians, cyclists, all kind of traffic you can accommodate in any section. And also you can make the sections quite wide, and they are quite effective because if you have a tube, for example, well, you always have this circular shape where you have areas which you don't use because you can't have a car driving really close to the wall. Um, but here, these are shapes which are yeah, typical, but usually we have kind of shapes looking like this, only with two tubes or three tubes, something like that. Go back. So, well, the characteristics of these kind of tunnels is that, well, they're suitable for various and relatively poor soil solutions. And that's because it's a buoyant structure. So not the full weight of this structure, this massive concrete structure is pushing it down. You have the benefit of Archimedes. He's a real talented guy from Greece in the ancient time. It pushes it up. So you need to make it heavier than water. Then it pushes it down, but you can limit that load on the soil. So that helps you to well, to limit the load on the soil. Furthermore, you have parallel construction processes. I will tell you later about it, but you can create the approaches in the same time as you create the tunnel elements on a secondary site. Well, there's manageable or low risk profile to the structure. You're capable to deal with severe seismic events. We build tunnels in Mexico, for example, but there are also tunnels built in Japan and also in other seismic areas, for example, as in Turkey. It needs a different approach because you need to accommodate this flexibility more for seismicity, but it is doable. And last of all things is that about 80%, 90% of all design and constructions works can be done locally. So local agencies, local engineering firms, local contractors can do the pouring of concrete and can calculate the sections, and only limited input is needed from international specialists. Are there any disadvantages? Yes, there are, because usually the first disadvantage which is brought up is the environmental impact of dredging. But if you
You have muted yourself, Marcel.
somebody
Yeah.
muted everybody, I think.
Okay.
So the disadvantage is related to dredging, but these kind of tunnels are usually built in areas in deltas where dredging is still a part of maintenance of your harbor. So it's manageable, and there are state-of-the-art dredging methodologies, and it's picked up by the working group, and they put up a publication which can be downloaded on the website. On the other hand, there are also possibilities from that because you get a lot of soil and you can do land reclamation. And a good example of it is that the soil which is coming from the dredging from the femur belt link is used to do a land reclamation and create a natural environment and build beaches around the area of the tunnel. So um, the construction is also limited impacting the shipping. So, for example, I showed you the picture of the Maas Delta tunnel being immersed, and it's only blockage the river for 24 hours. So you build a structure, you bring it in, you immerse it, and that operation only takes about 24 hours. But still, you need to manage that together with the harbor authorities. But usually, it's manageable and can be addressed properly if you communicate it well and if you consider them and take them into in the discussion early in the design process. So if I go back a little bit in time, I take the Rotterdam area as an example. The first immersed tunnel in Europe was about built in 1942. It's the Maas Tunnel. It's also in Rotterdam, and it's built during World War II. And it's a kind of different picture as you see from the pictures I showed before, with a small cranes and the small pontoons to immerse. Here they have a large construction to have it immersed, and they have divers going next to it to close the elements to each other. But it's completed in 42, and it's still functional. However, it was renovated in 1942. Sorry, renovated in 2017. And you can imagine that this tunnel here at the bottom, you can see it has a double floor, and it was heavily polluted by salt because of frost. So there was a lot of corrosion in the floor, and they removed the floor and remade it or restructured it, and they created a real nice new tunnel. And here on the side, you see that there's even space for a pedestrian or a cyclist to go through the northern side of Rotterdam to the southern or the other way around, of course. Also, this renovation took about 2 years, so there was a major congestion in Rotterdam. Not everybody was really fond of what's happening over there. Our option is that they replace bridges by tunnels. Here you see two examples. We had a nice bridge which is demolished and replaced by a bottleneck tunnel, and also a rail bridge, having a rail on about 10-meter high across the city, and that was transferred into a rail tunnel. And even if the capacity is the Benelux tunnel, it's also close. It was built in 67, this part, and it reached this capacity early 90s, and then they decided to create an extra Benelux tunnel. So they immersed it really next to it. So you see the very small distance between those, and they added this 1, 2, 3, 4, 5, 6, 7 tube tunnel next to it. Well, it's functional at the moment, and it takes a lot of relief on the traffic around Rotterdam. It looks like this. So there were architects as well involved, especially on the top part. But if you look to the port area of Rotterdam, then it's a very busy port, and you see all the tunnels being built over there. Then it's a major thing, and I can bring up this picture also for Amsterdam. They also have these kind of structures around their city, so it's actually something we do a lot in the Netherlands, but also we do it a lot around the world. So this is about the history and the things which are happening here. I come to the principle. The principle of immersed tunnels is really that you kind of make a box and you connect boxes to each other, and then you bring it, and then you after you connect these boxes to each other, then you have a tube and you can drive through it. And it all starts with a casting facility, and it's a traditional dry dock, and we have one specifically made for tunnels in the Netherlands, but you usually have them in your surroundings, and in your surroundings can be up to 100 kilometers, but you need um, depth to transport. So first of all, here 8 elements are being built. So here it's a 3-tube tunnel. I don't know actually which one it is, but you can create them in parallel, and then you create these boxes. And I think these ones are about 150 meters long and about 25 to 30 meters wide and about 10 meters high. You create them, and after you create them, then they're closed boxes. You close them with bulkheads, so then they can float. So the next thing is that you fill the dry dock with water, and then these elements start floating. And as soon as they start floating, then you can tow them. So what's happening is that you keep them parked until you need them, and then one by one you bring them to your immersion location. And that can be, if it's very close, it can be using winches actually. So if it's really close, within meters, 10 or 20 meters, you can use winches. But if you need a transportation oversea, for example in this case, then you use tugboats to just bring your elements at the immersion location. In this matter, there's nothing really on the roof of the tunnel, but you can imagine that you need boulders. These 2 boulders are there, but there need to be an access shaft and a positioning system and lifting lug hookups and things like that. And usually after you bring your if you after transportation to the project location, you start preparing for the immersion. And then the final day is really the immersion. So, and that's actually when all the risks are coming together. So you work 9 months on a project, and you need to bring in all the things, the gaskets and the things like that, and then you literally bring this thing to the bottom and bring it to its place. And actually that's the principle of it. And it's nice to have these kind of nice figures, but as an engineer I made it I have a few movies how this is done, from an engineering point of view. So allow me to go on with that. So after your element is brought to the location, you see here these are cranes, uh, uh, floating cranes, but you can use also pontoons. And what they do is that they lower down this element. Oh, I need to switch this off. Uh, yeah, yep, there it goes. So here on the left side, you see the element which was immersed before, and it's lower down to the bottom. And you see some details I will explain later on, especially on this side. So actually it's bringing it from top to bottom, but it's if you bring it down, it's not because you made it buoyant. So you need to make it heavier than water. So what we do is that we pump in water into the ballast tank. So here you see such a ballast tank, and we take water in from the outside. It's using pumps. You pump it in, then becomes somewhat heavier than water. And then with the lifting lugs, you can position it vertically exactly at the location. And if after it's on the location, I can go back a bit back here. I can't. if it's on this location, then there's a jack here that pulls it through to the previous element. So here it's pulling, and here you have a shear connection to have it positioned vertically and horizontally. And here on the back side, on the secondary side, we call that, we have a pin construction, which is lowering the element and landing on the pin on a tile. And this tile is installed before immersion. Let's see. So here's some more. So here on the inside, you see that there's the shear connection. So it's not only vertical, but also horizontally fixing the location. It's a beam and it's a catch actually. And now you see it's dragging the tunnel to the other previous element. On the secondary side, you see, so it's jacked to the previous element. And then you go to then we see the secondary side. There's the next one, the facility for the next element. And here you see the jacks, and they pull out and landing on the jacks. And with that, so you have the nose on the front and the jacks on the back, you can position it vertically exactly. So it's within centimeters or even millimeters accuracy that you can place these elements using this technique. I think it's a redo. Okay. So then your element is vertically positioned on the bottom. So it's here on the left side, it's connected to the previous element or to the shore. It's connected here with the GINA gasket. I will talk about that later. And there's some gap in between here. It's called the immersion joint. And that immersion joint is still full of water. And actually, there's water pressure all around this element. Otherwise, it will implode. So what we will do is that we pump out this water, and then we only have water pressure on this end. And then it pushes it to the other element or to the shore. And then it seals this this connection. So this is what happens then. So you reduce it, you bring in the water into a basin, usually inside. So you remove the water, well, there's air going in and water going out, and then there's no water pressure anymore. And the gaskets are closing the joint. So you have a closure, the joint is closed all around the circumference. And this GINA is a particularly nice detail because I show you here. So it looks like this, and it's called GINA because of Gina Lollobrigida. So, but she unfortunately passed away a few months ago. But she's named, well, this profile is named after her. I don't know why, but you may figure out. But if it's pushed together, you see that there's this nose, and it's not a very great picture. But if you push it further, you will get a triple seal. So this part will go to that area, and that one to that area, and then you have a triple seal all over the height. And after it has immersed and the bulkheads have been gone, they will add an extra gasket here called an omega gasket to have a double seal all around. This structure is actually it's just an I-beam. So an I-beam which is casted in, and there's a plate welded in there, and on the other side as well. And there are some options to inject afterwards. So there are injection hoses to avoid leakage. Then go to the pins at the end. The pins are really literally massive steel pins which are going through the floor. and of course you need to seal it, and there's all kind of sealant around there, and it's a lost structure afterwards. And what they do is that they push out the pins, and they're on these tiles, and these tiles will usually have a diameter of a few meters, about 4 to 6 meters, and about 1 meter, 120, 150 meter of thickness. And it positions this pin on it, so you can really position it correctly. And they measure the force through through the oil pressure in this hydraulic jacks. And that's important, which I come later to it, because you can't have this tunnel, well, balancing on these two pins and only on the other element. So what's going to do next is that we make a foundation for this element. So what we do, in Dutch we call it pancakes, and we have a system of tubes, and through the tubes we supply a water sand mixture, and they will turn out into pancakes, and we do that all along the length of the tunnel. And while we do this, we measure the pressure on the pins. So if the pins are relieving a bit, then we stop injecting, let it rest for a bit until we get some balance all over the length. And then it's really foundated vertically. But then it's not finished, of course, because it's still laterally movable. But that's something which comes later on. If you have this water pressure all around there, so if you push the elements to the previous one, then the last part, yeah, you need to close your tunnel, but then you cannot benefit from the water pressure. So we prepare, or usually a closure joint is prepared, and the principle of that is like this. So this is the element which has been immersed with the secondary end with the pins here. And this is the element from the other side or the shore or whatsoever. And the distance between this is about 1.5, 2 meters, something like that. It's, well, it's just too much to go with your car through. So we need to close this part. And what we will do is we create a box by adding to cast the concrete. So there's a plate on the bottom, you pull it up, and there's a plate on the side. Oh, and there's a, well, of course you need to fix the horizontal direction, and then you put the plates around, and then you can do your casting inside, and then you have your tunnel finished, and then you create the pancakes below that, and then it's vertically, it's founded on the bedding. Then you're nearly finished for the immersion project, but still, usually these tunnels are placed in a trench because you want to, well, you don't want to have the tunnel on the seabed, you want it to be below. So what we do, we dredge a trench and put the element in the trench, and after it's finished, then you fill out with sand, and you put on top a protection and for scouring, but also for dropping anchors, for example. And then it's finished. So then you can remove all the bulkheads and the ballast, and you exchange the ballast because, well, there's still ballast tanks in there with water, but you exchange that ballast water with concrete, which is a solid layer on the bottom of the tunnel. And well, you need less concrete than you have water because there's a 2.5 factor on the density. So usually you will have about 1 meter of concrete at the bottom here to keep it down, and usually we'll have some, well, it's limited on vertical direction on the load, which is about 20 to 40 kPa. Oh. So that's basically how you create this kind of tunnels. Are there any developments Yes, sure. Because well, we're humans and we always have challenges to go longer, go deeper, and go wider. And go deeper is something which has been done in the Marmaray crossing, which is about 60 meters of depth. So you have 60 meters of water on top of your tunnel, which is about 600 kilonewtons of water pressure. The Busan-Guyana fixed link also has 50 meters, but has also the challenge that it's in the sea, and also that counts also for HZMB, and that hold also the challenge that there were different soil characterizations along the length. So you have some parts which are have a which had a hard soil, and some parts had a soft soil. Going wider, well, that's something which is under research at the moment. There are challenges because there's a limitation on the amount of concrete you can use, because if you use more concrete, then it might not be buoyant anymore. So there's a balance between the amount of concrete you can use and the span length you can make. And there are two options at the moment, and they are both being applied. The first is to apply transverse post tensioning, which has been done in the Maas Delta tunnel. You see it here. Oh, by the way, this is the part of ballast concrete you see here. We put it to the side, but here's the ballast concrete to keep it down. But here you see the transverse post tensioning on the bottom and the roof. And another option is a steel tunnel. So you make a kind of sandwich structure, and that has larger capacity, but has some penalties on constructability. So you need to be sure that this concrete, which is high fluid, put into the boxes of these kind of structures, connects correctly to the concrete. I need to take a sip of water. Sorry. Sorry. This post tensioning is also an option for the Fraser River Tunnel, which is going to be constructed in Canada, and that will have 2x4 lanes, so a tube which is 4 lanes. So you can think of how many, well, you have a lane width and some emergency lane. So it will have a large span required. The next challenge is going longer, and longer is not really an issue at the moment. Of course, it's challenging because, well, up till now we made the Hong Kong Zhuhai Macau link, which is close to 6 kilometers. And the project of the Femern Belt link, there's a movie later on in this presentation, goes up to 18 kilometers of immersed tunnels. You can imagine that that will do something with safety and well, refreshment of air, things like that. So what they do in the Femern Belt is that they created special elements. And these special elements, this is the regular element. It has two traffic tubes and 2 train or rail tubes. And there are special elements, and those elements are deeper but shorter and wider. So what they do here is that because it's wider, you can park here on the side. So it's for emergency or for maintenance. And in this area, you can go down, and then you have a basement. And at the basement, you can apply any mechanical installation to have pumping facilities or well, installations or all kind of tunnel installations you might need to to facilitate your tunnel, for example. These are built, well, the elements are, the regular elements have a length of 200 meters. These have about 40 meters, 46 meters. And they're built, they're applied every 10. So every 2 kilometers, there's such special elements. So this is, well, this is a movie about the project. So I'm going to start the movie, and then I will tell you later on more about it, or during the movie.
This is one of Europe's largest construction sites. We're building the Fehmarn Belt Tunnel between Denmark and Germany, near the town of Rodbyhavn on the island of Lolland. The new link will be the world's longest immersed tunnel and the fastest route between Scandinavia and Central Europe. Following extensive preparations, the project is now underway. The first step in the construction phase is the large-scale work harbour to take delivery of the huge quantities of sand, cement, steel and gravel that are required to cast the tunnel elements. Behind the harbour, we're building a tunnel factory with 6 production halls for casting the tunnel's 89 concrete elements on a 24/7 basis. The standard elements are 217 meters long, weigh over 73,000 tons, and contain 2 tubes for the motorway, 2 for the railway, and a service passage. The tunnel elements will be immersed in a 12-meter deep tunnel trench dredged on the seabed. Dredging the 18-kilometer tunnel trench will produce 19 million cubic meters of soil, sand, and stone, which will be transformed into new beaches and land areas adjacent to the construction site. The tunnel factory will be the world's largest for concrete production. The construction site will provide jobs for several thousand people. What's more, the project will create even more jobs at companies in the region, supplying the site with raw materials, goods, and services. The finished tunnel will be assembled from 89 elements, cast incrementally in segments over a skeleton of reinforcing steel in large casting molds. Once the concrete is set, the molds will be removed, and the tunnel element will be pushed forwards towards the dry dock. This work will take place round the clock, with 9 weeks needed to produce 1 tunnel element. When the element is ready to be transported, it is sealed at both ends with a bulkhead, and the dry dock is filled with water. The element is towed out into the deep end of the dock, after which the water level is lowered to sea level. Tugboats will tow the element into position in the Fehmarn Belt. The ballast tanks are filled with water, and the element is lowered onto the seabed. The elements will be installed with millimeter precision along the length of the tunnel. Once maneuvered into place, the elements are pulled together and the water is pumped out. This creates a partial vacuum, which ensures a watertight connection. Finally, a protective layer of stone will be laid on top of the tunnel. Over time, the current will completely cover the tunnel with sand. Portal buildings are being constructed at Rodbyhavn on Lolland and Puttgarden in Germany, which will ensure that traffic has a smooth transition between land and tunnel on both sides of the belt. Once the technical installations are completed, the tunnel will open to traffic. People will then be able to cross the Fehmarn Belt in 7 minutes by train and 10 minutes by car. The world's largest immersed tunnel will be ready in 2029.
Okay. I hope that, well, it's a large video, so it might be lagging a bit, but feel free to look at the website. There are more movies over there. It's nice to tell you about that. This tunnel is initiated from Denmark and it's paid by Denmark, but it also has to fit the German requirements, which are a bit tighter than the Danish. So there's I did a lot of work in matching these requirements together, and especially on shear force. We had some large discussions, which were quite nice from a research perspective, but for the speed of the project or the continuity of the project, it took some time. The next one is the Busan Goi link, and you see here it's 2 bridges and a tunnel, and this is open sea, so it's not the Fehmarn Belt also, but there's no immersion operation yet. Will be somewhere next year, but here they have elements built in a building dock with 6 elements at the same time, and they have built this facility specific for this tunnel, and there's a lock here, so they can easily reuse the casting facility. And you see some transportation of this element, and while they're still shipping. So and the movie I'm going to show is about how this immersion process has been done from the immersion part, and that was been done by Structon Immersion Projects, which is a Dutch company, and they were in charge of the immersion operation. A lot of diving involved during this immersion process. Here you see a device to prepare the secondary part on the right location, because it was really a dynamic area of sea, and when it was on the bottom of the trench, sometimes it needed to move a bit sidewards, and they made a specific device to maneuver the secondary end, to move it sideways. This is emptying the immersion joint. So the water is coming in, and the Gina is being pressed. And then there's always a special moment to open the immersion joint and go to the next element from the previous element. So finally, I've some overview of some projects. I don't know how many time I've left. Is there still time, Roger?
Yeah, Marcel, you can take more time if you want, 5-10 minutes.
Okay. I've a few projects with 2 or 3 slides to highlight some things. This is the Coatzacoalcos, which is in Mexico. It's about 700 meters long, with 5 elements. It is very soft on soil, and it has it's heavy seismic. It's really on the border of these 2 tectonic plates. And the immersion was in 2012, and well, it's finalized. You see the casting basin, and well, it's finished, and they're really driving through it, of course. This is the Hong Kong Macau bridge link, and well, you have this large bridge, and it's there's an artificial island created, and connecting it, there's a tunnel, and that's specifically done for ship traffic. So the ships are not prohibited to or blocked by a bridge, which need to be opened or not. They can really go over the tunnel. Here you see this cross section. I don't have it better. Well, it's about 30K of this total link, and 6K is this immersed tunnel. And this is the casting basin. So here you see also the dock door to close the casting basin, and then they can remove this casting basin, having it floating, and then tow it out. And they also have this construction facility. So they pushed out the elements and then bring it sideways, and well, they can float literally up to this edge, you see. So this is the height of the area. So they
Your
can really
marker
floating
is
that.
not your marker is not visible, Marcel.
Oh, sorry. So this is better. So they can literally fill up till this height. So this part is floating, and then you can move it sideways here, having it lower, and then tow it out to the immersion location. This is what I told already. This is a nice overview of the Fehmarn Belt. It's one of the earliest plans. They want to have a ventilation island, but they recreated it with the special elements. This is the area where this large construction facility is, where they push out. But enough of Fehmarn Belt. I already told about it. This is a special project. This is the Eye Lake, and this is Central Station of Amsterdam. And here's really the city center of the ancient city of Amsterdam. And in the 90s, they the municipality decided to create a tunnel through the city center, which is a bored tunnel called the North-South line, and connected it to the northern side of the city through the Eye Lake, and to create a tunnel. So from here it's easier. Well, not really easy, but you can just immerse a tunnel from here to there. But below here, it's a delicate situation. You can't easily bore over there because of the foundation of the central station. So they decided to create an immersed tunnel below the central station. And well, at that time, this building was already 100 years old, masonry, and was on an historic heritage building. So what they did is they made a trench underneath it. So they removed the foundation of the station, put in bars, large heavy beams, and go back, and then really immerse underneath the central station. So you bring in your element from the Eye River and really immerse it down here. Was really challenging, to be honest, and also especially related to this masonry. Actually, it was my first project, so it's something which is real nice to talk about. Shenzhen, which is currently under development to create. It's also a bridge tunnel combination with an artificial island over here. And I think this is the last one. This is the Söderström tunnel in Sweden, the city of Abba, you might know. And here it's a connection of an NATM tunnel. So it's a tunnel created with explosions. It's on this side, on the Söderström side. And this side is the Ridderholmen side. And here it's the TAIym tunnel. And they constructed here a tunnel, an immersed tunnel of 3 elements. And it's quite special. Sorry, here's Ridderholmen. And on the other side, there's Söderström. And they created 3 of these kind of elements. And it's founded on piles. So actually it's more like a bridge underwater. It's not on soft soil, but the principles are still the same. You really immerse it. And here's top view. So here's Ridderholmen and here's the Söderström side, and this side is being done with the NATM method and TBM on that side. And you see here there are steel boxes, and these steel boxes were used because it's not very deep over there. And to immerse over there, you need to bring in the elements over there. And there was no, well, there's no casting area here to create that on site. So you need to bring them from farther away, but the depth was not enough. So what they did, they created steel boxes, which were filled with concrete afterwards. So they were really casted on site. And then, and after they finished it, they immersed it to the foundation. This is Shark Crossing, which is a project which is we do together with Calatrava. The architects might know him, but that's something we worked on for a long time already. But it's still to be decided whether this will go on. But it's also a bridge link combination, and especially this part where there's a connection underwater between highways, that will be the challenging part. Well, that's about it. So feel free to give something to the table to discuss or questions.
Yeah, Marcel, we have a lot of questions. Like, I'll just so first of all, the presentation was quite informative and quite unique, as I said before. So we'll come to the questions first. So yeah, first are all this thing. Yeah. So one is from Rolf. He says the ideal line of the submerged tunnel is a smooth concave parabola, but I assume that this will change depending on the type of the soil.
No, well, the alignment, the vertical alignment you are talking about, Rolf, is primarily, so you design is based on the vertical alignment. So you need to create a curved element, which is possible. So that's usually what we do. And also there's possibility to shape your alignment using the ballast concrete you apply after immersion.
Okay. The next question. So he's satisfied with the answer now. So the next question is from Abhinash. He has a question regarding immersed tunnel foundation design. He's asking at the basement of river slash seawater, there will be non-cohesive soil layers of different grades of soil masses up to some depth. How
Yeah.
we can do the deep foundation without any competent rock mass under hydrostatic pressure?
Well, the main thing is the tunnel. Well, of course, it weighs a lot of kilos because of the concrete, but it's a buoyant structure, so it helps to to limit the pressure on the soil. And So sometimes it's needed to apply some extra soil improvement. So we do that. For example, we did that in, I think we did that in Göteborg. But usually we can put a foundation and put a tunnel on it. And because the load is actually, it's quite limited.
Okay. So I think now we have another question is any forces considered in design regarding tsunami, etc., if any? So any forces you have considered, like natural
Mm,
disasters like tsunamis?
Yeah, there are, well, if it's coming to tsunami as a kind of water load, yeah, you always take into account some water rise or sea level rise or things like that. Specifically to a tsunami, it's not it's well, you take into account flooding of the tunnel, but that's when water is coming in.
In
But um, regarding dynamic loads because of a tsunami, that's something we do not encounter, but that's also because the tunnel is not open in the sea. It's covered by soil and it's not really vulnerable by any waves or currents.
it's like a homogeneous structure inside
It's
the,
a homogeneous structure
yeah,
within the soil. So,
yes.
yeah.
So yeah, just piggybacking on that question. So is there any effect of the dredging and everything because of the low pressure created by tsunami at some point or something?
No, not really. No, the dredging is, well, it's temporary.
Hmm.
And if you well, you need to have a stable trench. So the angle of the steepness of the trench is of course of importance. So it needs to be stable, and you need to do this geotechnical analysis on it. But after coverage, yeah, you well, yeah, it's there.
And Gaurav Chaudhary also has another question, that is, what is the general requirement of minimum dead water above immersed tunnels to allow ship to cross?
Yeah, that really depends on the waterway you cross. So, for example, if you have a very busy seawater way, so it might go to 20 meters or 25 even. But if it's very local ones, like like in Harlingen, for example. Oh, maybe I can stop sharing. I think that might be
Yeah,
nicer.
yeah.
Um, if, for example, in Harlingen, it might be 2 or 3 meters. There's no minimum because it's well, the water load is there anyhow. It doesn't matter whether you have 10 centimeters above it or 20 meters. It's only a difference on the roof. So or at the bottom, you have a larger Q load on it.
And Mr. Gaurav also has another question, that how do they control dredging in water? Controlled dredging in water.
Yeah, well, the Dutch are quite famous about it, but it's you can really control it on a decimeter or a centimeter scale, and you can really measure the bathymetry after dredging on a grid size, and well, because you create a foundation afterwards, it will be filled up anyhow. By the way, I showed you the sand foundation, which is kind of traditional foundation, but there are also possibilities to have a gravel foundation, and that's something you prepare on beforehand. So you lay a bed of gravel, and then you immerse on the gravel bed.
Okay, I think Mr. Gaurav is satisfied with the answer. And
Okay.
Onur has a question. How do you perform long-term behavior monitoring of these structures? What should be considered?
Yeah, well, usually well, in the past we built structures like this for 50 years, but in the meantime we built structures like this for 120 years. Um, And it's a topic of discussion at the moment to monitor this. So I can only speak for the Dutch situation at the moment, but they're going to set up a monitoring program for tunnels. On the other hand, what we see in the in reality outside is that if there are settlements over time, then they occur at the beginning. So they occur immediately after installation of the immersed tunnels, and even within 6 months. If it doesn't happen after 6 months, then nothing happens over the years after that. But well, settlements, especially differential settlements, so over joints, for example, that causes a major headache, because if you have a differential settlements, you can have leakage because of the GNAs, which are only on compression sealing.
And yeah, he has actually done that. What is the planned life? I think it is clear.
Yeah,
And
depends on the standards, but usually, well, I know that the femur belt was, I think it's for 120 years, and the regular Eurocode is 100 years. But it depends on where you built in the world. Depends on the governing or the applicable standard for the local situation.
yeah, requires as per the local authorities. Yeah.
Exactly. Yep. Yep.
So, Mr. Gaurav also has another question that do we have some standard codes for the design of immersed tunnels?
Um, Yeah, usually we, well, if we are abroad, usually the standards of the regular concrete standards are applicable. And usually we define a set of requirements based on, well, in the Netherlands, we have called ROK, which is it's a guidance for these type of structures. And then you might think of how much pressure you need on the foundation, typical things related to the tunnel, overballasting and things like that, but also in the execution. So there are standards, but not every country have its own standards. So most of the time we rely on the European standards for these kind of tunnels. But but in the end, it's still regular concrete, which is subjected to bending moments and shear forces. So yeah, then you can rely on your local standards for it.
Okay. And I also have some couple of questions from my side. So one of it is about what about the ventilation? Like if the tunnel exceeds more than some length, so what we do is we provide a ventilation shaft somewhere in between. I'm just talking about the conventional tunneling.
Yeah.
So in this type of tunnels, if the like for example over here around 3 kilometers, that is I'm not expert in ventilation, but generally
Mhm.
in 3 kilometers they don't give a ventilation shaft or something. But
No.
after 3 kilometers, if the length is more, we have to give some ventilation shafts in between. So for the tunnels which are exceeding this much, this length, so how the ventilation is provided, like shafts and all?
No, we actually we put ventilations within the envelope. So we take them into account on the roof to have an airflow through the tunnel. But we don't provide any ventilation shafts, which is quite unusual to have that somewhere in the middle
Yeah,
of the water. So usually you will have something at the beginning and at the end, or on both sides, and then you have a ventilation system which is on the roof. And well, of course, there's active monitoring and of that during
air
its
and all.
service life. Yeah, yeah.
Yeah, and one more question is this: the longest tunnel which is to be constructed. So it is around 18 kilometers, right?
Yes.
So how do you accommodate the curves over there, like the curves in that? Because the curved section will be a bit more in the width of the curved section will be more. So how do you accommodate for the seal, the waterproofing seal, and all for that thing?
You mean to the curves in the lateral or in the vertical direction?
And the horizontal curves, not the vertical, the
Yeah,
horizontal
well,
curves.
well, you try to be as straight as possible in the lateral direction. So, but
But
there are, but still, then you just cast in a curve. So you saw some of the pictures, I think. Let me see whether I can show you some of them. Straight. The femur is almost straight, huh? So it's
so, but if you have a straight tunnel, so there is not a risk of like the risk of drivers like getting a monotonous background and feeling asleep type of thing, because this is taken into consideration, right? So
yeah.
here,
That's in the for the femur, that's topic of research, and they well, I know only from the beginning of the design that they thought of projecting things on the wall to not have the well, to have some distraction and not have a
yeah,
monotonic design. But here you see this is a curved section
okay.
here.
So you make the curve in the center of the segment. So
Yep,
the
yep,
start point and the end point is
yep,
the same length. Yeah, that's
yep.
it. And we have a question from Madhu. She is, do immersed tunnels have emergency exits?
Let me see where I can show something. Yes. Here. Yep. So what you can see here, this is a double tube. That's the old one for the Benelux tunnel. And there's a central gallery which acts as an emergency exit. So in the tunnel, there are doors where you can enter this emergency exit and then you can go out. And it depends on the local authorities whether it's needed or not, because we built also tunnels which don't have this, and they say, okay, well, you need to go through the tunnel and exit from there. But usually you will have a central gallery where you can have your emergency exit.
Just continuation of this question. So I have actually seen in both the figures that the emergency exit. So is it the doors are used for the accommodation of the vehicles also, the width of the doors, or it is just for the people over there?
It's only for the people, yeah, because well, I think the current regulation says that this area needs to be 120 or 140 or something only. So it's really tight, but it's an emergency exit.
Yeah, because usually, I don't know, but usually here what we have is we have passenger evacuation cross passages and vehicular evacuation cross passages. So the cross passage for pedestrians is a bit smaller,
Yeah,
and for the vehicular it is a bit bigger to accommodate the turning of the vehicles and all.
yeah.
So yeah, anyone has more questions? Okay, I think they'll sleep upon it and then they will email it to us.
Yeah, sure.
Yeah,
Be my guest to send us some questions or inquiries or
yeah,
visit the website to see or there's some information on the ITA website. There's an owner's guide for and a design guide for immersed tunnels, which is very informative. But if you need more information, just reach out and I'll be happy to answer your questions.
yeah. And I just have one more question. Is this presentation, can we upload it on our website, or do you need to take some permissions from some authorities or something?
Well, it will be on the server, I guess, as a video. So I would like to keep it like that. And
Okay. No, because some people have used the videos, so they have to take some permissions and all. That's why I was asking.
yeah. No, I linked the videos and well, the most pictures are um uh well are open. So are all
Yeah.
actually.
Okay. So thank you, Marcel, for such a
You're
wonderful
welcome.
webinar, for this very unique webinar on immersed